As was discussed in the previous modules, crime analysis and intelligence analysis are in fact distinct fields of analysis, albeit with a common purpose, that being to identify criminals and criminality. It is quite common for the techniques to be grouped together under a single banner, for example, criminal intelligence analysis, or for the phrases to be used interchangeably to describe one or another of the techniques. In fact, in 1992, a European subgroup of Interpol, the Trevi Subcommittee, fashioned a definition for crime analysis which identified 8 different forms of crime analysis. Depending upon the source consulted, both terms are used to depict generic descriptors or specific techniques. It comes as no surprise, therefore, that there is confusion about the terms. However, to the layman, the distinctions are perhaps less important. What is important is the utility of the work. In this module, we will expand upon the concepts of what is meant by the terms criminal intelligence analysis and crime analysis, hopefully in the process providing a clearer delineation between the two and demonstrating the efficacy of each application. TREVI is an acronym for Terrorism, Radicalism, Extremism and Violence International. Take a moment and write 2 sentences. One that defines what you consider to be information, and similarly, one that defines what you consider to be intelligence. It is common practice for the layman, the investigator and the specialist intelligence officer to use the words information and intelligence interchangeably. In fact, in some countries there is no actual word in the language for the word intelligence. In others, the word intelligence has such unpleasant connotations that the correct use of the word is avoided. Generally speaking, a failure to use the words correctly will have little or no impact, except to say it propagates the fallacy that they are one and the same, and perhaps undervaluing intelligence in the process. Information and intelligence are not the same. In the English language, intelligence and information have different meanings. The dictionary defines information as knowledge communicated or received concerning a particular fact or circumstance, a collection of facts or data, example, statistical information, whereas intelligence is defined as the faculty of understanding, the evaluated conclusions drawn from information. We can see from these definitions that the two are not the same. Intelligence is something beyond information, and therefore it is of greater value. As you have heard, the dictionary defines information as knowledge communicated or received concerning a particular fact or circumstance, a collection of facts or data. Put another way, information or data is the raw material, and as such its characteristics may sit along a continuum between extremes. For example, true to false, accurate to inaccurate, reliable to unreliable, valuable to worthless, and so forth. Information is the basic building block of intelligence. Potentially, it is everywhere and of every type. It is often disorganized and disparate. It is the stop and check report, crime statistics, information report, informant information, calls for service, police officers' observations, demographic data, a telephone number, telephone billing data, a vehicle registration, a snippet of conversation overheard in a bar, anything and everything that might inform the matter being examined. It should be noted that information or data may be quantitative or qualitative. Intelligence is the value-added product. It is simply the amalgamation of information and analysis. Usually it is not possible to rely on one piece of information to unambiguously inform the actions or the intentions of a criminal or a criminal enterprise, nor when in possession of multiple pieces of related information can we expect that the information will provide a complete picture. It is very unlikely, particularly in complex cases, that the investigator or analyst will be in possession of all the information, even when the offender has been arrested and cooperates. In order to fill the gaps, to tell the investigator something that he or she doesn't know, it is necessary to subject all the available information to the intelligence process. It is this process that transforms the information into intelligence. The intelligence process, using the key component analysis, provides a structure that generates an inference explaining what has, is, or may happen. To use an analogy, the pieces of a jigsaw or puzzle pieces represent individual pieces of information about an incident, and the picture on the completed jigsaw represents the incident as a whole. The investigator or analyst will often be faced with a situation where pieces of the jigsaw are missing and the picture is therefore incomplete. As a consequence, in order to depict the whole picture, it is necessary to fill in the gaps or infer what the complete picture may look like, in which case the complete picture may be different from reality, and therein lies the skill of the analyst. Intelligence is information that has been processed, been subjected to analysis to produce an inference, depicting a potential explanation of that information. Intelligence is more than information. Only the human mind can provide that extra something that makes sense of the information. Unfortunately, there is no single universally accepted definition for intelligence. Each authority or intelligence community having its own preference, albeit they very often say or mean the same thing. Some authorities would define intelligence as information designed for action, assessed information, information that is significant or potentially significant for an inquiry or potential inquiry. The definition used by Anacapa Life Science is: intelligence is the product resulting from the collation, evaluation, analysis and interpretation of information. A definition produced by the International Foundation of Protection Officers, IFPO, reads very similar. Intelligence is a product created through the process of collecting, collating and analyzing data for dissemination as usable information that typically assesses events, locations or adversaries to allow the appropriate deployment of resources to reach a desired outcome. In essence, Anacapa's version and the IFPO's version are almost identical in meaning, both drawing upon components of the intelligence cycle which incidentally varies slightly between agencies and will be discussed in another module. The IFPO definition overtly draws upon more of the cycle's components with its reference to dissemination. And now our definition. Intelligence is a value-added product created from the processing of raw information through the intelligence cycle and comprising of an inference that informs beyond the original data set. This does exactly the same thing using the version of the intelligence cycle prevalent in the UK. Direction, collection, evaluation, collation, analysis and dissemination. You will note that instead of making the components of the intelligence cycle integral to the definition, we have made specific reference to the intelligence cycle itself. This gives the definition the flexibility to be used across jurisdictions, where differences may exist in respect of the intelligence cycle components. The component within the intelligence cycle that makes the real difference to raw information is analysis. Without analysis there can be no intelligence. Omission of any of the other components would undermine the value of any intelligence product produced, but it is the analysis that is fundamental to the transformation. Now that we have an appreciation of the difference between information and intelligence, the question now is, what is criminal intelligence analysis? Earlier in the course, reference was made to quantitative and qualitative information. It is predominantly the latter, qualitative information, that forms the building blocks for criminal intelligence analysis. Quality of information is things like stop check reports, informant information, police officer observations, a telephone number, a vehicle registration, a snippet of conversation overheard in a bar, etc. It is specific information about a crime or criminal as opposed to aggregated data. As is typical in these cases, there are a number of definitions depending upon the authority consulted. However, in practice, criminal intelligence analysis analyzes pieces of information about a specific crime or criminal, with a view to understanding the nature and extent of the criminal enterprise and the culpability of the persons involved. It should identify investigative leads, entities of significance, and anomalies within the information. Techniques employed include link or association charting, event charting, commodity flow charting, activity flow charting, and other data visualization techniques as appropriate. Link analysis is known by a number of different names depending upon the authority consulted. It is known as link, association, and network analysis. It is a technique used to examine the associations within a network. It assists in identifying key functions or roles and attributes of individuals within the network under examination. It also may identify strengths and weaknesses within the network, and importantly, it allows inferences to be drawn about criminal behavior and activity. Link analysis charting is a potentially powerful tool, and as such it should be considered as a core technique. The technique and others illustrated in this module are examined in greater detail in subsequent courses. Like other techniques, commodity flow analysis can be known by slightly different names. For example, commodity analysis and flow analysis. Again, the name used is of little consequence. What matters is the application of the technique. Commodity flow analysis is the study and analysis of the flow or transmission of a commodity between people or organizations, with a view to understanding the criminal enterprise under examination. Very often the old adage, "follow the money," holds true. Commodity flow analysis, amongst other things, can reveal otherwise remote, inaccessible players in a criminal enterprise. Event charting analysis, in actual fact, comprises of two different techniques, the event matrix and the event chart. Here we can see an illustration of an event matrix. Both can be used to examine crime-related events. Those events may be purely retrospective, for example, looking at a street robbery that has occurred. Conversely, it may be used to discover information about a crime in the making, for example, looking at a cash-in-transit robbery. The techniques are used for placing and presenting events in a chronological form so that the times of events and the relationships in time become clear. Our final illustration is activity charting. This is a technique used to examine the sequence in which activities occur for an occurrence to occur. Activity flowcharts examine the modus operandi of the criminal or the sequence of activities directed towards some other objective. The technique focuses on the sequence order, the way in which activities depend upon each other. Its usefulness lies in its ability to depict the sequential nature and weaknesses of the criminal activities examined. The charting technique briefly alluded to here are examined in greater detail elsewhere in our course. Crime analysis, as we have already discussed, is often used as a generic term to describe all forms of crime and intelligence-related analysis. In keeping with prevalent attitudes and practices in the United States, we subscribe to the premise that intelligence analysis and crime analysis are separate, albeit related disciplines. You may recollect that we postulated that the origins of crime analysis go back as far as the mid-1700s, if not back further. However, in the modern era, crime analysis probably has its roots in the 1920s and 30s and owes its early beginnings to August Vollmer, who predicted the requirement for crime analysis to support effective management of patrol operations. As we have already alluded, his protege Orlando Wilson in the first edition of his book Police Administration, which was published in 1950, described crime analysis as a means of determining the locations, time, special characteristics and similarities to other criminal attacks, and various significant facts that may help to identify either a criminal or the existence of a pattern of criminal activity. In June 1992, the Trevi Group, the forerunner of Europol, agreed upon a definition for crime analysis. It stated that it was the identification of and provision of insight into the relationship between crime data and other potentially relevant data with a view to police and judicial practice. Yet another definition is provided in the book Crime Analysis, from the first report to the final arrest by Stephen Gottlieb et al. Is a set of systematic analytical processes directed at providing timely and pertinent information relative to crime patterns and trend correlations to assist the operational and administrative personnel in planning the deployment of resources for the prevention and suppression of criminal activities, aiding the investigative process and increasing apprehensions and the clearance of cases. Whilst there are clearly some differences in the variety of definitions we have seen, the reality is that in 80 years the meaning has remained pretty constant. Simply put, crime analysis is the examination of crime-related data for pattern and trends. Many crimes are opportunistic, random and unpredictable, and as such are unconnected. For example, a man is killed by his spouse in a domestic incident. A woman is raped whilst out on a date. A pensioner steals food from a store, or a laptop is stolen from an unattended vehicle, and so forth. Conversely, crimes that are not isolated incidents, that are repeated, are the basics of crime analysis. For example, the repeat theft of or from motor vehicles, the street robber stealing mobile telephones from children, the house burglars targeting a particular housing estate, kids smashing school windows every weekend, drugs-related acquisition crimes, and so on. Crime analysis is particularly suited to high-volume crimes and as such is particularly reliant upon quantitative data. The aim of crime analysis is to identify patterns and trends in an effort to predict when and where the offender will strike next, so that strategies can be developed to eradicate the problem. Quantitative data measures some characteristics or attributes involving quantities or numbers, usually expressed as a number or statistic. It includes things like calls for service, crime reports, non-crime incidents, stop searches, persons arrested or summoned, performance figures such as response times, and so forth. However, quantitative data is not just restricted to the data normally recorded by law enforcement agencies, as there may often be other factors at work that impact on crime and criminality. Over the years, there have been a large number of studies carried out by researchers from various disciplines, for example, sociology, criminology, and psychology, examining the causes and origins of crime and criminal behaviour. As a consequence, it is known that crime does not exist in isolation, and that there are a number of factors which may affect the volume and type of crime that occurs. Such factors include demography, people's lifestyles, topography, the physical characteristics of a place, modes of transportation and the highway system, economic conditions, income, poverty levels and job availability, cultural factors and education, recreational and religious characteristics, family conditions, weather or climate, police and support personnel numbers, crime reporting or recording factors, public attitudes to criminality, effectiveness of other elements of the criminal justice system, and so forth. From each of these different types of data sets, correlation may be found which helps inform and ultimately address the crime issue under consideration. Crime analysis techniques focus upon the identification of patterns and trends within crime and incident-related data. At a superficial level, This might be the examination of simple aggregated or summative data. For example, the number of burglaries that have occurred each day, or the number of persons arrested, and so forth. However, data, and police data in particular, often has a number of characteristics and attributes that can reveal patterns and trends that might not immediately be apparent at the superficial level. But when subject to drill down and metadata extracted thereto, unidentified patterns or trends may become apparent. Data has both temporal and spatial characteristics, which can be examined both at a superficial level and also in some detail. Metadata is data about data, data that explains attributes and features of other data. Date and time values contain a number of additional dimensions that can be harvested to support further analysis. For example, hour of day, day of week, week of year, etc. The various characteristics may be tabulated or cross-tabulated, plotted on a frequency chart, subjected to statistical examination and correlated against one another. The aim in the first instance is to describe and understand the data, extract any facts, and to identify any patterns or trends. It's usually about identifying a problem as opposed to a specific manifestation of that problem. In other words, a series of crimes as opposed to a single crime. Statistics, even at a very basic level, are often viewed as something you do if you have to, but otherwise they are to be avoided. Such an attitude belittles the importance of statistics. Statistics is a science that provides appropriate processes to collect, organize, classify, present and interpret data sets, the objective of which is to extract information from the data in order to better understand situations that the data portrays. In a nutshell, statistics aids understanding. Descriptive statistics can be used to summarize the data, either numerically or graphically, to describe a sample. Basic examples of numerical descriptors include the mean and standard deviation. Graphical summarizations include various kinds of charts and graphs. Inferential statistics are used to model patterns in the data, accounting for randomness and drawing inferences about the larger population. These inferences may take the form of answers to yes-no questions, known as hypothesis testing, estimates of numerical characteristics, descriptions of associations, known as correlation, and modeling of relationships, known as regression. Statistics are examined in more detail in other modules. Tabulation is quite simply the act of setting out data in a table. See Table 1. A table is both a mode of visual communication and a means of arranging data. The use of tables is persistent throughout all communication, research and data analysis. Tables appear in print media, handwritten notes, computer software and many other places. A table such as this, examining only one variable, may be used to illustrate the frequency distribution of a single variable. As seen in this example, the number of burglaries recorded each day on a specific beat is a simple example of tabulation. Tabulating data in this manner is very often the first stage of collecting or organizing data. A table consists of an ordered arrangement of rows and columns. A column usually identified by a name which may consist of a word, phrase or numerical index. The intersection of a row and column is called a cell. A more complex form of tabulation is cross-tabulation, often abbreviated as cross-tab. See Table 2. This involves a two-dimensional table displaying two or more variables simultaneously. In other words, the variables are usually presented in a matrix format. Each cell shows the count for each pair of variables, in this case beat and crime type. That is, each cell contains a single cross-tabulation. Cross-tabs are frequently used because they are easy to understand, they appeal to people who do not want to use more sophisticated measures, They can be used with any level of data, nominal, ordinal, interval, or ratio. Crosstabs treat all data as if it is nominal. A table can provide greater insight than single statistics. They are easy to construct. In statistics, a frequency distribution is a list of the values that a variable takes in a sample. It is usually a list ordered by quantity showing the number of times each value appears. The first example shown in the previous slide was of a simple frequency distribution. A simple tabulation such as this has two drawbacks. When a variable can take continuous values instead of discrete values, or when the number of possible values is too large, the table construction is cumbersome, if it is not impossible. Therefore, a slightly different tabulation scheme based on the range of values is used in such cases. For example, if we consider again the number of crimes that occur each day in a frequency table, it might look like the table shown here. Similarly, the bar chart or frequency chart would look like a chart shown. Working with frequency tabulated data is much simpler than operating on raw data, as it can simplify voluminous data, making it easier to understand. Correlation, often measured as correlation coefficient, indicates the strength and direction of a linear relationship between two random variables. In other words, a measure of association between two variables. It measures how strongly the variables are related or change with one another. If two variables tend to move up or down together, they are said to be positively correlated. If they tend to move in opposite directions, they are said to be negatively correlated. An example would be the number of patrol officers deployed against the number of people arrested. Crime analysis and criminal intelligence analysis are different but related aspects of analysis, and whilst they can and do exist as separate functions within an agency, it is a mistake to think that they are wholly independent. Each have a potential to inform the other.